Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
In this video, we are going to see different types of sources and their classification, namely independent and dependent sources. Moreover, we will see difference between them, and different types of dependent sources depends upon the quantity on which it depends. Source is nothing but a basic element which gives energy in an electric circuit. There are two types of sources that we can have. One we can say independent source, and other type is dependent sources. As name suggests, independent source is a constant source whose value do not depend upon any other voltage or current. Whereas in dependent sources, the value of the source does depend upon some other voltage or current. There are two types of sources in independent source. One we can say a voltage source, and second is current source. So what voltage source will do? It will provide a constant voltage irrespective of any amount of current taken from it. So it means maintain constant voltage across two terminals. Whereas current source, irrespective of amount of voltage across it, it will always maintain constant current in the circuit. As far as dependent sources are concerned, there are four classifications. So let's do it separately. So it depends which voltage and current is being controlled by which voltage and current. Meaning we will have four combinations because we are having a two parameters, current and voltage. So let's list out the four combinations. So first is voltage controlled voltage source. So voltage controlled voltage source can also be called as VC, Vs. So we are having a circuit. In this circuit, there are two ports, meaning two terminals are given. Let's consider this is a port AB and this is a port CD. So what we are saying, there is a voltage across A and B as VAB. Based on this voltage, a voltage is developed over here, okay, and it is shown with a diamond shape like this. So remember, dependent sources are shown by this diamond like structure. And let's consider here this is the voltage developed, which is VCD. So what we are saying, this VCD is depends on this voltage. So it's a voltage source. This voltage source depend upon this voltage, and there is a factor. We call that factor as mu. So basically what we have done, we have represented a VCD as a voltage source which depends on another voltage VAB present in the same circuit. Okay, if you see carefully, we can get this mu as the ratio of two voltages. So it is a dimensionless quantity and it called as voltage gain. So this is about voltage controlled voltage source. Let's go ahead with the second classification. It is voltage controlled current source. Can be considered as VCCS. So it depends upon voltage only, but I am getting a current source at the output side. So once again, we'll consider the same two-port, two-terminal circuit. So this is A and B having a voltage VAB. This voltage will control the current at this side, and it is represented with a diamond shape. Just to interpret, it is a dependent source, and being a current source, it will have an arrowhead. So this is a current which is nothing but ICD, and I can say this ICD is depends on this voltage. Okay, and so I can call this as GM into VAB, where GM is a constant. If I solve for GM, I will get GM as the ratio of current and voltage, and current to voltage is a conductance. Since ICD is a current of output port and VAB is the voltage of input port, I can say this is transconductance. So this is about a voltage controlled current source. Let's go ahead with the third classification, that is current controlled voltage source. Can be considered as CCVS. This time in the network, we will have an input current which is flowing from A to B. So we'll consider, so the input current over here is IAB, which will control the voltage at the output side in order to get a voltage source of this nature. We can say this voltage is VCD. So VCD, which is a voltage, depends on this current IAB. So we'll call this as R into IAB. Okay? So we will get this particular relationship. Now over here, if you see carefully, you can get the value of this constant, which is R, which is nothing but VCD upon IAB. So it's the ratio of voltage and current, nothing but a resistance. But there is a voltage and current of a different poles. So we call this as trans resistance. And finally, we come to the last classification, that is current controlled current source. Can be considered as CCCS. The name suggests both the sides will have a current. So in the circuit, the input side, the current is IAB, which will control the output side current ICD. So we can say ICD is being controlled by IAB by the factor beta. I can get beta as ratio of two currents ICD and IAB, a dimensionless quantity which we called as current D. So here we have seen in our dependent sources we will be having a four types. Depends upon which quantity is being controlled by which quantity. Let's go ahead with the significance of a dependent sources. In practice, dependent source does not exist. So let's list out some important points. Then while we are studying the dependent sources, the question may arise. Basically, dependent sources can be used to analyze the circuit. Meaning what? In a big circuit, sometimes it may happen that there is a constantly one particular voltage and current we are getting which depends on some other current and voltage present in the same circuit. So what do we do? Instead of drawing and analyzing the same circuit again and again, I can replace that entire part of a circuit by either a dependent current source or a dependent voltage source. Okay. So the best example is whenever we analyze the bipolar junction transistor as an amplifier, there we need to draw its large signal or small signal analytical circuit using a dependent source. So the best example is large signal or small signal amplifier analysis of BJT. Where the whole concept of a base current, collector current, base emitter voltage, collector emitter voltage, transconductance, and input impedance, everything can be represented with the help of dependent sources. So here we have seen different types of independent and dependent sources. More importantly, the classification of dependent sources and its significance in the electronic circuits. Thank you.